Welcome to this explainer. Okay, today we're diving into the fascinating and, let's be honest, slightly terrifying new world of agentic commerce and the protocols that are actually making it secure. We're looking at a fundamental shift in how the internet operates, and I am so excited to guide you through this. So let's kick things off with a pretty massive question that is quite literally rewriting the rules of the internet right now. When an autonomous agent initiates a payment, how do we prove who actually authorized it? I mean, think about it. If your AI assistant spots a great deal and buys it while you're fast asleep, how does the merchant know it wasn't a glitch, an AI hallucination, or just an outright hack? Well, to figure that out, we're going to run through 6 rapid-fire topics. First, the AI checkout problem, then the AP2 trust layer, the 3 cryptographic mandates, real-time versus autonomous actions, privacy and payment rails, and finally, standardizing the agent economy. Let's get right into it. All right, Section 1, the AI checkout problem, the broken assumption of modern e-commerce. Let's start with the absolute core issue facing retailers and payment networks today. The entire internet was basically built on one giant assumption, that a human is sitting there at a keyboard actively clicking buy. That shared understanding is what makes digital commerce work right now. But agentic commerce, it completely shatters that assumption. Instead of acting directly, we're now delegating. And when you remove the actual human from the immediate checkout flow, the underlying infrastructure just totally breaks down. And without a human actually there, we run straight into a 3-pronged crisis of trust. First up, authorization. Did the user genuinely give the specific agent the authority to buy this specific item? Second, authenticity. Is the agent acting on a hallucination, or is this the user's true intent? And third, accountability. If a fraudulent transaction happens, who takes the hit? Is it the user, the agent's developer, the merchant, the payment processor? Without a common protocol to answer these questions, AI adoption in commerce would literally hit a brick wall. Moving right along to Section 2, AP2, a new trust layer. We're engineering trust into the agent economy. And this brings us right to the solution introduced by Google and over 60 partners, the Agent Payments Protocol. So how does AP2 actually engineer this trust? Well, it uses something called verifiable digital credentials. These are essentially tamper-proof digital objects that create an ironclad audit trail for every single purchase. It's an audit trail that can never be denied or forged, because any attempt to modify it instantly breaks the cryptographic signature. It shifts intent from being just this implicit assumption into an explicit, cryptographically verifiable artifact that actually travels with the transaction. You can really just think of AP2 as the missing puzzle piece in the modern AI tech stack. While Anthropic's Model Context Protocol gives agents their tools, and Google's A2A protocol lets agents talk to each other, AP2 is the secure, dedicated rail they call when real money actually needs to change hands. It completely replaces the incredibly risky practice of having AI agents scrape web pages and use stored credit cards. Okay, Section 3, the 3 cryptographic mandates, breaking down the lifeblood of the protocol. Let's pull back the curtain and see how this actually works in practice. Every single transaction goes through this 3-part life cycle. First, you have an intent mandate from the user. Second, a cart mandate from the merchant. And third, a final payment mandate that the network actually authorizes. Each mandate is a verifiable credential signed by the user's wallet or the agent's key, and then passed around as a highly secure, standardized digital data package. I absolutely love thinking about the intent mandate as a highly secure cryptographic permission slip. It puts strict boundaries on the AI's behavior. For instance, it might say, buy a pair of running shoes, size 10, under $150, white or gray. The agent simply cannot exceed the scope of that exact request without coming back to re-prompt you. If it tries, the cryptographic signature just flat out fails. Next up, Section 4. Real-time versus autonomous actions adapting to human presence. Let's see how this life cycle shifts depending on whether you're actively shopping or if your agent is out there buying things while you sleep. There's actually a massive difference in how these transactions go down. In a human-present, real-time scenario, like if you ask an AI, buy me a sweater under Euro 100 right now, you actively sign off on the specific cart the agent shows you. But for autonomous, human-not-present tasks, saying something like, buy those limited sneakers the exact second they drop next Tuesday, you pre-authorize those detailed boundaries up front so the agent can execute it later. And this right here introduces the whole concept of delegated trust. Even when you aren't at your computer, the agent is continuously monitoring conditions in the background. The second those conditions are met, it automatically creates the cart mandate on your behalf. Because you originally signed that intent mandate, the merchant and the payment processor have total cryptographic certainty that your AI agent hasn't gone rogue. It gives us a fully auditable transaction without you needing to even be awake.
All right, Section 5, Privacy and Payment Rails, Selective Disclosure and Stablecoin Integration. So what exactly happens to your privacy when all these complex cryptographic objects are bouncing all over the internet?
Well, AP2 and MasterCard's Verifiable Intentt use this incredibly cool tech called selective disclosure. It essentially acts as a smart cryptographic filter. This means every party only sees what they absolutely have to see. The merchant sees the line items and your identity, but zero details about your payment instrument. The payment network sees the amount and the payment instrument, but they have no idea what specific items you're buying. Your privacy is enforced by hard math and architecture, not just some company's privacy policy. And it gets better, because this protocol is completely payment method agnostic. Sure, it supports traditional credit cards, but it also natively treats stablecoins as first-class citizens. And why is that such a game changer? Because AI agents transact at machine speed, often for fractions of a cent. Traditional cart interchange fees average around 50 to 80 cents a pop, which totally breaks the economics of micropurchases. Stablecoins solve this completely by settling for fractions of a cent on-chain, with launch partners like Coinbase and MetaMask leading the charge. Now, to make that crypto side actually usable in the real world, routing layers like EcoRoute step in to seamlessly settle the AP2 payment mandate across different blockchains. So if your agent happens to hold USDC on Base, but the merchant demands to be paid on Solana, the protocol handles that cross-chain liquidity atomically. That means it fulfills the cryptographic record and the actual settlement instantly, in one single unbreakable step. Finally, Section 6, Standardizing the Agent Economy, Building an Interoperable Future. Let's zoom out a bit and look at how this standardizes the broader agent economy. 60 plus. That is the massive number of launch partners jumping on board to align behind this open standard. We're talking heavy hitters like Google, MasterCard, PayPal, Salesforce, Adyen, and more. Seeing this level of industry consensus is super rare, and it really just proves how critical this infrastructure is right now. And the really smart thing here? Merchant adoption is just incredibly flexible. Merchants can integrate via a direct merchant agent, responding directly to intent mandates. Or they can go processor-mediated, where they just let existing processors like PayPal and Adyen handle all the complex cryptography behind the scenes, without changing their current commerce stack at all. Or, for sure, they can go completely stablecoin native. By acting as a completely vendor-neutral cross-rail protocol based on W3C standards, AP2 prevents the massive fragmentation that would inevitably happen if every single credit card company forced developers to use their own proprietary rules. While MasterCard Agent Pay and Visa Trusted Agent are powerful on their own, they can actually just plug straight into AP2 as payment funding instruments, keeping the overall intent layer totally open and interoperable. I think this quote from MasterCard's chief digital officer really just hits the nail on the head. In this paradigm, trust becomes the product. Because when autonomous systems are the ones managing our money, the actual speed of the transaction matters way less than our absolute confidence that it was done correctly, transparently, and safely. So, throughout this explainer, we've looked at the exact cryptographic framework that is preparing the global economy for agentic commerce. The infrastructure is literally being laid down as we speak. But the ultimate question I want to leave you with today is this. When commerce becomes fully autonomous and the guardrails are invisible math rather than a plastic card in your pocket, are you ready to delegate your trust? Thanks for joining me on this explainer. See you next time.